Have you ever wondered how levels are created in games like Angry Birds? Every structure, every pig, every block, you know, don't seem to be careful playing. But did you know that many of those levels can be created automatically by artificial intelligence? Today I will tell you how a group of researchers at the Australian National University developed a system capable of generating levels that are not only varied but also stable and solvable, meaning these levels can be beaten. A giant leap forward in the world of automated video game design. What is procedural generation? Procedural generation is a technique that allows content to be created automatically, like worlds, levels, enemies, or even missions, using rules and algorithms without designers having to do everything manually. The result, games with an almost infinite amount of content, enormous variety, and unique experience for each player. But of course, this is easier said than done. In games based on real physics, such as Angry Birds, each level has to respect physical laws, maintain balance, and offer a real challenge. And drawing lines to the challenge. If the AI plays blocks incorrectly, the structure may collapse before you even start playing or be impossible to win. Therefore, the goal of this project was to create an algorithm capable of generating variable, stable, and solvable levels. So, a little resume about the Angry Birds challenge and the three main conditions. You know, in Angry Birds, the player must launch the bird from a slingshot to knock down the structure and eliminate the pigs. Behind this simple mechanic lies a lot of physics, like weight, trajectory, balance, explosion. The proposed system analyzes all of that. Each level generated by AI must meet three main conditions. One of them is variety. The levels should not be repetitive and each structure should have the different shapes and materials. And with that, different bears to solve the level. The second one is the stability. The blocks should not fall on there or crumble prematurely. And the third is the solvability. A player, or rather a specific AI, can win the level with a reasonable number of shots. To test this, the researchers use AI agents deployment in the international AI birds competitions, where different programs attempt to solve levels automatically. Only if one of these agents manages to pass the level, it is considered valid and passes the filter. And then, how does the algorithm work? This generator follows several well-thought steps. One of them is the building structures. Here it creates a structure from blocks of different shapes and sizes, which can be made of wood, stone, or ice. It also mixes different types within the same row, making each structure more natural and less predictable. The second step is overall stability and analysis. This is where physics come into play. The algorithm evaluates where the structure will support its own weight, even testing what will happen if they rudder cycle. If the structure fails the test, it is discarded and other structure is generated. The third is the intelligent distribution of peaks and PNT. Peaks are placed in strategic position, neither to protect nor to ease. And PNT is also at analyzing how much damage it can cause and whether it is close to weak points to add more excitement. The fourth step It's the selection of materials and type of beer. The system uses logic rules. If there are many ice blocks, then add more blue beers. And if there are more stone blocks, they will add the black beers. That adjusting the type of the challenge. And the last step is the difficult and solvency verification. Finally, the level is tested with several authentic agents. If no one of them manage to beat it, if with reasonable numbers on attempt, the level is discarded. Only those can be beaten make into the final game. This process ensures that every level generated is playable, consistent, and challenging. Results and analysis. The researchers analyze hundreds of levels created by the AI. They use metrics such as frequency, how often the blocks appear, linearity, how evenly distributed the structures are in the space, density, how much space the objects occupy in the level, and leniency, how difficult it is to be in the level. The results was impressive. The levels were varied, balanced, neither too empty or not impossible to solve.